Hello dear all, this is Sadanand Malik welcomes you all in entire physics, and today we will discuss about electrostatics in vacuum. And here electrostatic, first of all, here electrostatic is made with two words, electro plus statics. It means when a static charge exists, then how the electricity or electric field will be produced. We have to study about those for a static charge here. So we will start from a static charge Q placed at a particular point. Then it is found that around this static charge there is a field, there is a zone within which when another charge particle try to enter, then it will experience a force, either it will be attractive or repulsive, depends on the nature of two charges Q1 and Q2. Around this charge Q1, the zone in which another charge enters and experience a force, it is known as electric field of the first charge Q1. So electric field may be defined as, electric field is a zone around a static charge in which when another charge enters, then it will experience either a force of repulsion or force of attraction. For like charges, it means if Q1 and Q2 having the same charge, then they will experience, or Q2 charge will experience a force of repulsion when enters in the zone of electric field of Q1. So here for like charges, this force is repulsive. Similarly, if unlike charges, means if Q1 and Q2 are different charges, it means Q1, either Q1 is positive and Q2 is negative, or Q1 is negative, Q2 is positive. So this is the condition of unlike charges. In this case, a force within the electric field that is experienced by the charge Q2 is attractive force. So here in this case it is attractive force. So this is the concept of electric field. Now let us see how this electric field may vary around the static charge. First of all, if we observe this condition, then we will find as the charge Q2 is at an infinite distance from the charge Q1, then there is no force between the charge Q1 and Q2. Why? Because at an infinite distance the effect of electric field is vanished. What is the reason for this vanishing of electric field? Let us discuss. So actually what happened, this electric field is produced due to the electric fluxes, means the electric lines of forces which are emitted in all the possible directions from the charge Q1, from the static charge. So here these are the electric fluxes that those are emitted from the static charge Q1 in all the possible direction. So these are the electric fluxes, or sometimes known as electric lines of force. We see that as we move away from the static charge Q1, then the separation between two electric fluxes goes to increase. That's why the strength of electric field goes to decrease. And as we move towards the static charge Q1, it is found that the separation between two electric fluxes goes to decrease. That's why the strength of electric field goes to increase. So here it is found that at an infinite distance when the charge Q2 is placed, then the separation between two electric fluxes becomes infinite. That's why the charge Q2 will be unaffected by the charge q1. It means here the charge q2 is outside the electric field that is produced by the charge q1. So this is the first concept of electric field. It means that the strength of electric field depends on the separation or distance from the static charge. So first thing is distance r. This is the one factor upon which this electric field strength depends. Next, let us discuss the next factor upon which this electric field strength will depend. So here actually if we increase the strength of this charge, means if we increase the magnitude of charge q1, then what will happen on increasing the magnitude, means increasing the charge with some coulomb, then what will happen? Actually the electric fluxes which are emitted in all the possible direction will increase in number. So here first of all black lines indicates the electric flux. On increasing the strength of q1 including the black lines, these blue lines also shows the electric flux. Then it is found that the number of electric flux increased. That's why it is found that when a charge q2 is placed at a particular point within the electric field of charge q1, then the force that is acted upon the charge q2 will be more. It means on increasing the magnitude of static charge q1, the strength of electric field also increased. That means here the second factor is magnitude, that is q. So this is the second factor upon which the electric field strength depends. On the concept of these two factors on which this electric field depends, we can define the formula for electric field intensity. Electric field intensity, it is denoted by E vector. Actually electric field intensity is a vector quantity. So here if we consider the magnitude of electric field intensity, then it is proportional to the strength of magnitude of the static charge, that is suppose q1, and magnitude of electric field intensity is inversely proportional to the square of the separation from the static charge q1. So combinedly we may write magnitude of electric field E vector, electric field intensity E vector is proportional to q1 upon r square. On removing or replacing this proportionality sign with the equality, then we have got is equal to 1 upon 4 pi epsilon naught q1 upon r square. So here 1 upon 4 pi epsilon naught, where this 1 upon 4 pi epsilon naught is proportionality constant. Where epsilon naught is called electric permittivity and its value is 8.83 into 10 raised to power minus 12 Faraday per meter. This is the value of electric permittivity of the media for the vacuum. So here this is the formula for electric field intensity. So now if we consider its direction, then what should be its direction here? So here the direction of electric field intensity is along the electric flux, along the direction of electric flux. It means that if we consider a static charge q1 from which electric fluxes are emitted in all the possible directions, then the direction of electric field is radially outward from the static charge q1. Means in this direction or in this direction, radially outward direction will give the direction of electric field intensity. So here if we consider a unit vector, that unit vector r cap, means here this unit vector r cap is a vector along radial direction in outwards. So here we may write the formula for electric field intensity. E vector is equal to, its magnitude is 1 upon 4 pi epsilon naught q1 upon r square into unit vector r cap. So here actually this unit vector gives the value, unit vector r cap is equals to vector r should be divided by mod of r, means the same quantity, the same vector quantity if will be divided with the magnitude of itself, then it will give the unit vector. So this is the definition of unit vector, and here this is the final formula for electric field intensity. It is very much useful in electrostatic, or we may consider it is the basic formula of electrostatics. So here now let us define the intensity of electric field in words. In words, the electric field intensity may be defined as so here if within the electric field, if we consider a unit surface area, suppose within the electric field if we consider a unit surface area, means here its one side is unit, other side is also unit, means 1 meter, then the total number of fluxes passes through this unit surface area within the electric field is called electric field intensity. So here electric field intensity will give the number of fluxes. Now let us count the number of fluxes here. So according to this figure we may find 1 2 3, means here 3 is the intensity of electric field, because through this unit surface area 3 fluxes or 3 electric fluxes pass through the unit area. That's why here in word we may define electric field intensity means number of electric fluxes passes through unit surface area in unit time or in 1 second within the electric field. So this is the word definition of electric field intensity, means number of electric fluxes passes through the unit surface area in unit time within the electric field. So this is the word definition, and by this way we have completed the topic of electric field intensity. Thank you very much.